for this. So again, TASIS is graded. Your grade is in D2L, so please check D2L for your grades. The only missing in D2L grade are your homework that was due last week. So I will put them today. Two, you didn't get any. The key for the midterm is not posted anywhere yet because of I still have a couple students haven't done the test yet. So hopefully once it's done, I will post the key in D2L and I will send an email to you. And I also will make a video about the key, how you solve those keys there. So and if you have any questions, you can email me. Third is there's no homework due this Wednesday because last week is your test day. So no homework due on this Wednesday. Okay. And I believe that when you guys took your test, you should have chapter 7, 8, 9, and 10 notes. Except for Nathaniel, I don't know you went to the school to get the notes back or not. Please go back to my my office to get my notes, Nathaniel. So your finals will consist of chapter 7, 8, 9, and 10, the last 4 chapters. It doesn't consist of 1 to 6 that we did in the midterm. So your final is the last 4 chapters here. We're gonna start a new formula paper here because same thing happens to you guys in the finals. You are allowed to have one front page of formula or cheat sheet or whatever you want, and then and I also provide you the StatCrunch syntax so you guys are familiar with it. So those are the few things that it's kind of similar. And then you ask me what is the final looks like. The final is very similar to your midterm. That means the format. You have like 6 open-ended questions, and then you have the around 12, 13 multiple choice questions. And then in your finals, it's the same time. It's on August 1st, Thursday. That is the last day of class. You'll be on campus, the same room, CBT 160, same time, 10 till noon. So everything is mostly the same, except now we only cover chapter 7 to 10. Okay. Anyone have any questions for me before we start chapter 7? And I just want to point out to you that the last 4 chapters, 7, 8, 9, and 10, is a little bit difficult. When you guys look at the homework, you find out the homework is not, it takes you a bit more longer time to do your work here. Okay, just want to point out to you that when you guys do your homework, it's gonna take a bit more long time to do your homework here. And then once we come to chapter 8, just a little preview for you guys. Chapter 8 will look something like this, where we only have a question and then you have a one front big page empty. So chapter 8, this is what happens in your test. In your test, this is the chapter 8 stuff where it's even more work. So this one question you have to do like 7, 8 to 8 steps. So it's been repeated. So 8, 9, and 10 is like you see one question like this and then the whole page is blank. Okay, so just want to point out, so you will be doing what we call as doing an inferences, okay, or inference statistics. So let's talk about what is an inferential statistics in this case. So inferential statistics in this case is where we use the sample data to make inferences. Inferences means prediction about the population parameter. Okay, so what we do in this last 4 chapters, or in this case in the rest of the world of statistics, is performing what we call as an inferential statistics. So statistics comes with a few like groups. We did what we call as a summary statistics. Summary statistics is where you find a mean, median, mode, all those things. And then we do second one, we do probabilities. We do quite a bit of probabilities, discrete, normal, continuous, Then the next part of statistics here is what we're doing is the inferential statistics here. So what is inferential statistics is we try to make prediction. Okay, so the last 4 chapters is trying to make prediction. So like example will be this coming election. Who will win this coming November election here? We do not know who is winning because we can only make inferences about it. We can only make predictions about it. And how do we make predictions who will win this? I mean, you can see a lot of pooling is talking about this person is winning or that person is winning. So who will be winning for the for the presidents? We only collect the data from the sample. Okay, so this is what the world of statistics is. Okay, just want to point out to you. So the population is big enough. We do not have time to study the whole population, and it costs a lot of money to study the whole population. What we do is we can predict the population by getting the sample. Okay, so what we found in the sample, as long as you pick this sample randomly, or sometimes samples means a few of the samples, just not just one. If you pick them randomly, we can use this sample to predict the population. Okay, so that is the beauty of statistics. That is what we do for statisticians. If you're thinking about doing a statistic jobs, we always study the sample, okay, and we always use this sample to predict the population. Now, there are few, if you guys remember when you do the summary statistics, the mean, the median, the mode, the mid-range, so on, so on, we can actually we can predict all those population parameters of like the mean, the standard deviation, the median, and so on. But for this class, we only study 2 types of statistics here. We're doing population parameter. We only do population mean and population proportion. Okay. Now, population proportion, the word proportion is the fancy word for decimals or percentage. Okay. So these are the fancy words. So but we'll be using a lot of the word proportion. So once you hear the word proportion, it means decimals or percentage. Okay. So we only study 2 types of population parameter here, the mean and the proportion here. If you continue taking more statistics class, then you will be doing the median, the standard deviation, the variance, and the rest of the stuff that you guys study here. But since we're only doing 2, and the reason why I do 2 here is because of types of data. Okay. For the population mean, population mean is only used for quantitative variable. Okay. And then like height, weight, temperature. So this is where you do your population mean. Okay. And for the population proportion, we will do categorical types like eye color, the yes, no questions, the elections, the coming election. So when you guys do your chapter 7, 8, 9, and 10, you notice that you will break into 2 parts. One part is for the population proportion. So if you look at 7.1, population proportion, this is where we use the categorical variable type. Like all the questions you see in 7.1 will be like yes, no, eye color, it's a categorical type. Okay. However, when you guys look at 7.2, 7.2 is where we do the population mean. So for the population mean, we are doing quantitative type like like test score, height, weight, and so on. And same thing happens in chapter 8. In 8.2, we are doing proportion. And then in 8.3, we are doing mean. Population mean. So you find out that, and then same thing in 9 and 10. If you look at chapter 9 and 10, So this is kind of like want to point out to you that is because that when you do your homework, you find out, oh, 7-1 is all proportion. Oh, 7-2 is all mean, right? Proportion mean, right? But when you do your test, everything is jumbled up. So the first thing you guys need to do when you do the test is to read the question carefully and to figure out, are they doing population proportion or are we doing a population mean? Okay, just want to so you guys need to know this. So there are two types of inferential statistics we'll be doing here in this class. One is doing what we're doing called to make an estimate value. Estimate value in this case means that we are doing the confidence interval. Okay, so we call it the confidence interval. You will learn this in chapter 7. Okay, so entire chapter 7 is where we're doing confidence interval piece. And then chapter 8 is where we perform what we call as a hypothesis testing. Okay, so these are the few, so as you guys, so this is the inferential stats. And then in chapter 9, we are also doing confidence interval and hypothesis testing, same thing in chapter 10. So 7, 8, 9, 10, this is all what statisticians do. We do inferential statistics. You probably, if you are doing in this, if you're a statistician, you're doing this work type, you probably will earn around like 100 to 150,000 a year easily. Okay, so so what is confidence interval and what is hypothesis testing? You will learn this in chapter 7 and chapter 8, and in the test, this is where I will test you. So when you read in the test, as I mentioned, first figure out, are they categorical or are they quantitative? And then the second thing you need to figure out, are they asking to find the confidence interval or are they asking you to perform a hypothesis testing? Okay. Usually the hypothesis testing is the one that I mentioned early on. You got a lot of blank page here. This is the hypothesis testing. And the confidence interval is usually is not that much. Okay. So you will learn this. This is quite important. Okay. Let me show you an example of a confidence interval. I'll just take so election poll is one of them that is famous. Let me see. I was thinking about looking for this. Usually is election poll will be the one that always see if I can find any election polls that is the most important. This is mainly to talk about what is only talking about 60% accuracy. Okay. Nope, I cannot find anything, but I think you see this before, so I will give you an example of a confidence interval here. So we are doing a 7.1, we are doing confidence interval for population proportion, means it's a categorical variables. So the best part that we do here is the election piece, so it'll be easy for us to do this. So let's say that if you look at current newspapers or even CNN or ABC or Fox News or whoever the newscaster is, because it's coming election, so they did their own little survey here, and they always will say this, for the Democrats who will win this election is 48% plus minus 4%. So this is what we call as the confidence interval. And then they will do one for Republican. They will give you a number and then they have a plus minus some percent in this case. Okay. So some of you saw this before in the newspaper or in somewhere else. So this is what we call as a confidence interval. So what is this 48% stands for? This 48% means that it is what is called as the point estimate. Okay. So point estimate is a single value or single point to approximate estimate the population parameter. Okay. So this 48% is what we call as your best point estimate. I'm going to call it the best point estimate. So sometimes in the test, especially in the multiple choice, I will ask you what is the best point estimate? The 48% is the one that we talk about is the best point estimate in this case. So how do we? So for the sample proportion, P hat, we call this P hat. The best point estimate in this case is the population proportion P. So in order for us to find out this 48%, this 48% is called the sample proportion P hat. Okay. And this is the best point estimate, we call that as the population proportion. And how do you find this sample proportion, P hat? P hat is found, the sample proportion is found by using formula of X over N. Okay. So what is X and what is N? Okay, so right over here. X in this case is the number of success. And N in this case, the little n, is number sample size. That means how many people we have. Okay. Or sometimes you say number of trials. Okay. So so what we do in this case is we divide them. For example, if you talk about this 48% confidence interval, we will how do we find this best point of estimate? We figure out how, let's say you want to do this in this class. I will say, okay, raise your hand. How many of you will vote for Democrat? Okay, example. Let's say, I don't know, 20 of you raise your hand. Okay. And then how many students in this class? Let's say 43 students in this class, example. Okay. So what do? Is I just divide these two up. Oops, sorry. I'll add on to that. So I will divide these two up. So 20 divided by 43 times 100. If you want to make percent. So it's 46%, 46.5. So this best point estimate in this case will be 46.5%. Okay. So this is how they use the to figure out how this number is if it's a proportion piece. So the sample proportion is calculated by X over N, where X in this case is 220. In this case, how many students vote for Democrat over 43. And then we will do the same thing for Republican, but we kind of know that we do not need to call students to raise their hand, those who vote for Republican, because if 20 vote for Democrat, then we know 23 will vote for Republican. So for Republican case, is 23 over 43, right? So so this is for the other side. So usually when you guys do the confidence interval in this case, usually what we call as is a binomial case, means that you only have two outcomes. Usually we try our best not to have multiple outcomes. If you do have a multiple outcomes, like eye color, you got in more than two eye colors, right? If you have more than two outcomes, then you unfortunately you are not able to use 7.1 in this case. Okay, so 7.1 is only you have binomial, which is two outcomes. But if you have more than two outcomes, then you have to take another statistic class to do more than two outcomes in this case. Okay, so this is one of the most important section here. And again, if you are really interested in being statisticians and you're doing what we call as inferential statistics here, then I would strongly suggest you to pay a little bit attention in this case. Okay. So this one is easy to calculate, because if 46.5% vote for Democrat, then you just subtract this from 100. That will be how many percent of students will vote for Republican. So we around 53.5%. Again, this is just an example. And again, so this will be also the best point estimate for Republican. So now I can do another one for Republican. So in this case, Republican will be uh 53.5% plus minus maybe 4% or something else like that. Okay. So this will be something that you will see a lot in the news or in the newspaper or in CNN or wherever the newspaper classic. But however, usually, as you guys know that when the election comes, we don't have just Democrat and Republican. We have a lot of others group like independents, Green, and so on, so on. So that's why mostly people do not use 7.1 to calculate the election piece because the election is not a binomial case. The reason why I say binomial is because majority of us do work for either Democrat or Republican. I mean, there are quite a few, not a lot of people who work for independents or the other groups. So we just mainly concentrate on these two, Democrat and Republican. So that's why, but if you really go do an election work here, you have to consider about the rest of those groups, although it's only a tiny percentage of people who will vote for those groups. Same thing happens to gender, male and female. As you guys are familiar with right now, we got a lot of gender groups, right? Uni gender or whatever you why all these different genders you guys see, right? So that's the reason why that again in our class to make things easy because we follow 7.1 to have a binomial too. So we only concentrate on just male and female. So that's why mostly what we did here is mostly is two groups, although that it can be more than two groups. And if it's more than two groups, as I mentioned, you have to go on to the next class, next statistics class to study that. Okay, let's take a look at this example here. So this example says that in a Pew Research Center poll, 70% of the 1,500 randomly selected adults in the United States believe in global warming. So what is the sample proportion p hat? Now, don't forget the symbol here, p hat. Now, so as you remember that the sample proportion p hat here is found taking x over n. But this question does not provide us X. They provide us the percent. So to make it easy, the sample proportion in this case will base on the percentage. Again, the word proportion is the same thing as probability and percentage. So your answer in this case is not 70. You just need to change it into decimals. Okay. So proportion is decimals. So do not give 70%. Otherwise, you get it wrong homework. I'm still going to give you correct in your test if you want to put it in percentage, but in your homework, make sure you know it is decimal. So the sample proportion in this case is 0.70. And then the next question asking is, what is the best point estimate for the proportion of all adults in the United States who believe in global warming? So again, when they use the word all is the stands for the word population. Okay. So that means this question is asking about what is the best point estimate for the population proportion who believe in global warming. So as you guys know that the answer here will be your sample proportion. So so that means your answer in this case will be the same as what is the sample proportion. P hat is, I'm going to put down P hat here. So this is the sample proportion symbol. P hat will be 0.70. Okay. So if a question anytime mention about what is the best point estimate, you just look at the sample proportion p hat. Okay, that will be the sample the best point estimate in this case. Okay, so now we have a few notation. We just did number of success. We did the sample size. There is a typo on this n here. I just need to cross it out. So if you guys have so please cross this n out. This is a typo in this case. This is actually will be replaced by E, capital E. Okay, so this is replaced by capital E. So what is that is capital E is called the margin of error. Okay, and what is the margin of error? The margin of error in this case is this. This is the margin of error. I'm going to do this in purple. So the plus minus 4% or the plus minus 2, 3, 1 depends on the result. This is called the margin of error. Okay. What MOE? Okay. Or sometimes you just call it E to make things easy. What is this margin of error? A margin of error is the most maximum of error that you can perform in this case. So usually when you do a confidence interval, you do have you have two numbers. One is called the best point estimate, and then the other one is called the margin of error E. Okay. Now, so we do have, so once you got this, then you get yourself a confidence interval. So a confidence interval is a range or an interval of numbers used to estimate the true value of a population parameter. Okay. In this class, you should know how to construct it, and you need to know how to interpret it. Constructing this, please use StatCrunch to construct it, and I'll show you how to do it. And interpretation, in order for you to interpret confidence interval is right here. This is how we interpret confidence interval. And I'm going to put few stars in here. So if I box things out and make few stars in here, means that this is super important. So make sure you put this in your cheat sheet for your test in the finals. Okay. So this is how you interpret. Now, usually the confidence interval is a range. So a range means you do have a low minimum and a maximum or lower and upper limit here. But if the question is yeah, so the point estimate in this case is the number in front here. So which is the number that to predict the population parameter. The best point estimate is given us by what is the best point estimate is the sample proportion p hat. And the sample proportion p hat is either found by taking x over n, or doing what we call as a 70%, giving us in the question as a percentage in this case. So this number, 48% or 53.5, these numbers are what we call as your best point estimate. And it comes from the sample. Okay. So is that all right, Emily? You will find it a lot. I will go through that a lot in this case. So you will see some examples and so on in this case. Okay. And then we have two P's here. So you need to watch out for the P's in this case, the notations here. One P, this P by itself is called the population proportion. Okay. And the p hat in this case is called the sample proportion. Okay. Or sometimes we call this as your best point estimate. Okay. So the formula to find this, there are two ways. One way is taking x over n to find the p hat. Or in the question, they will give us in percentage. Okay, like this 70%. So every time when you do see this, that is usually is a p hat. Again, which stands for decimals or percentage or probability, or in this class called proportion. Okay. Now, sometimes the question did not provide us number of success. So number of success can be also found by taking n times p hat. Okay. So if you remember what we did in chapter 1, the very first section, that do how many people have tattoos if this many percent out of this many people have tattoos, right? You remember that? And then make sure you know that we cannot have a 0.3 people, because there's no such thing as a point, like 28.3 people, right? So because you cannot, have a 0.3 people in this case. So it has to be a whole number. So for like example, in this case, if you want to figure out what is X number of success for this example that we'll be doing, okay? So if you're talking about the X for this, so what you need to do is you just need to take 1501, this is the N, which is the number of people that they survey, multiply with the percent, in this case is 0.70. Again, change to decimals. Okay. So in this case, take your calculator and you just take 1501 times 0.70. So this is 1050.7. And again, we cannot have a 0.7 people. So you have to round it to the nearest whole number. So this would be 1051. Okay. So if a question is asking you what is X in this case, or what we call this as a number of success for this question example that we have here, you have to take these two numbers and multiply and make sure you do your normal rounding, to do that. Okay, so 105. So now I'm going to put all this into the formula. So make sure you guys know that this is important. Okay. So the first formula that you see in this case, or thicker. The first thing we're going to do in this case is we call this as P hat, which is called a sample proportion. In order for you to find that, you take X over N. Okay. So again, I will say this is your sample proportion. And X in this case is your number of success. And N in this case is your sample size. How many people we have. And then if you do some math work or what you learn in algebra, does anyone remember if I want to solve for X, how do I get rid of N? Remember?
That's right.
This is a redivide. So what's opposite of divide? We multiply. So if you multiply N on both sides, you find out that, I'm just showing it to you right now. So if you multiply N on both sides, this N and N will cancel, right? So you will get X equals to NP. So this is, I just remove it so you guys can see it. So you can also find X by multiply N to that side. So you get N times P hat. Okay. So so this is the other formula that you see on here. So when you see this, see this two formula here. Oops, sorry. So you will see the two formula in this case. So you notice that in order for you to find that, you just multiply N to the P hat here. You will find that that is the other formula in this case. Okay. So this is the first formula for your finals here. And this is called how you find the sample proportion, or sometimes we call this as your best point estimate, BPE. So short form it BPE, best point estimate. Okay, that's your P hat. And then this is how you find the number of success. Okay. So why I'm pointing this out to you is because sometimes in the question, they will ask you for best point estimate. And sometimes in the question, they will ask you for the number of success. Or in other words, when you use StatCrunch, a StatCrunch wants you to put down the number of success. If a question did not provide us the number of success, you have to use this grid formula to figure out. Otherwise, you use the best point estimate. Okay. Now, there is also another formula here. Yep. The next formula we have is a margin of error. So as you guys know, that margin of error is this plus minus 1, 2, 3, 4% that is found in the confidence interval. So margin of error in this case is actually you use a formula of taking the upper limit minus the lower limit divided by 2. in parentheses. Okay. So so this is the next one I will point out to you. Is the second formula in this case. So yeah, we got some formulas already on this. It's called the MOE, which is short form for margin of error. Is where you take the upper limit minus the lower limit, in parentheses, divide this by 2. Okay. Now, what do you mean by upper and lower limits? This is where it's found in the confidence interval. So when you do a confidence interval where you have this 48%, let's say, plus minus 4%, can someone tell me what is the lower limit and upper limit of this confidence interval? So for the lower limit, you just take the best point estimate, 48%, subtracted by the margin of error. So 48 minus 4, so you get 44%. And then for the upper limit, instead of subtract, you add. So 48 plus 4, this is 52%. So this is what we call as your lower, and this is what you call as your upper. Okay, so when you try to find a confidence interval in using StatCrunch, StatCrunch will give you this result. They will give you the lower and upper limit. They will also give you the 48%, which is the best. This is what StatCrunch result will give it to you. However, StatCrunch will not give us the margin of error. So how do you find this margin of error, E? The 4% in this case is you take the upper, in this case, 52. Oh, sorry, put parentheses around it. Parentheses, 52, subtract from the lower, 44. Close the parentheses, and then divide this by 2. So you get 4. So 4 is your margin of error in this case. So this is the formula that, the easiest formula that we will use in this class. Otherwise, the margin of error that you'll be using is going to be super tough. So when you do the help me to solve this and so on, they will give us a very difficult formula. Okay, you will see it a bit down there. Okay, the next page. Now, then the question will ask is like, so that means that really, this coming election, 44 to 52% of this is for the population. So don't forget what you're doing here is the confidence interval. It is used to predict the population. So some of you will be, and this come from sample. So this 48% plus minus 4% come from the sample. Okay, and as I mentioned earlier on, what we do inferences is where we take the sample to predict the population. So what we're trying to do is we try to take this to predict the population. That means that 44% to 52% of the people who go and vote this coming November gonna vote for Democrat. Okay, again, this is for population, everyone. Then some of you ask me, how confident are we? Okay, how accurate? Is that always 100% accurate? That means really the 44 to 50% will vote for Biden this coming election. The answer is not 100%. If it's like everything 100%, then you will know when we rain, when will be snow, right? Because then you'll be 100%. But you can tell when you look at all the forecasts, it's always like 12, 20, 30. If it's a really 80, 90, 100%, means it's for sure it's going to be rain or snow or have this weather. So for unfortunately for this kind of things, we call this as confidence level. So how confident are we? Okay. So when you have a confidence level in this case, this is how it's the degree of confidence is the probability of that the confidence interval actually does contain the population parameter. So that means that how confident, what's the probability that this population parameter will be actually contained inside this confidence interval. assuming that this estimation is repeated by a large number of times. So again, when I want to do this, I'm not just doing this one time. I'm not just getting, oh yeah, this is just from one class, right? I will actually have to do this a few classes, not just few, maybe 50 or 60 times, okay? So usually we will use a 95% confidence. So you kind of notice why that everything we did is always 5%, right? Everything like statistical significant 5%. The probable everything that we talk about, everything we done here is all about 5% or less, 5% or less, 5% or less. This is the reason why we do this is because of what we call as the confidence level. So we always want a 95% confidence. So this is why that when you look at this 95% confident that this people who vote for Democrat will be around 44 to 52%. Only 95%. That means you still have 5% chance of not making it. Okay. So that means that the 5% is the dots, or that means the population will not be successfully doing that. Okay, so we call that alpha, the 5%, is the alpha in this case. Okay, so we have a new symbol in this case. So if 95% is a confidence level, the alpha in this case is 5%. Now, can we switch the 95% to a different percent level? The answer is yes. It can be 90%, it can be 99%, it can be whatever percent. If it's a 90%, then the alpha is 10, which is opposite of 90, which is 10%. If it's a 99%, then the alpha is 1%. Okay. Now, so later on, you will learn what is this alpha called. Okay, we have a name for it. It's called a type of error, but because there's so many errors here, so we do not want to get, I'll just point out, this is called significance level. Okay. So the alpha in this case, because you will learn that in chapter 8, we call this as a significance level, which is totally opposite of confidence level. So 95% is confidence level, significant levels will be 5%. So you will learn again, this is just the first day you're picking this up. So you will see this in the whole chapter, the rest of the semester here, the last 3 weeks here. Next, as I mentioned, you need to know how to interpret lots of stars here. So in order for us to interpret, first thing is, this is what you do. And you have to fill in the box here, the lot of blanks here. So this VR, this is where you put down your confidence level. This is where your confidence level belongs to. 95%, 90%, 99%. Some of you will ask me, David, so what are we going to do in the test? What percent are we using, since you can be all these percentages? It will be stated in the question. Okay. Yes, it's very similar to that, but what we're doing here is two completely separate things. So that is statistically significance, and this is confidence interval. So this, you are in different topics. So we, again, statistical significance, we kind of like, you are in the different topics. And the only similarity between significance and all this confidence level is this 5%. So you find out that a lot of things using this 5% here, but what you're doing here is totally in a different, it's two different things. Okay, so there are two totally different things. So so usually that's it's kind of like, I don't want to bring it up to tell you guys that in the world of statistics, statisticians can always cheat or lie, or not cheat or lie. It can be manipulative. That means the statistician can change the statistics for the likes that he or she wants. Okay, so what do I mean by that, class, is that, oh, 95% is I don't like this number, so I'm going to increase the 95 to a 99% or 90%. So statistician can actually manipulate this statistic to its favor, so to its like. So there is a few books written down that, for this case. So that's why a lot of statisticians can change numbers around because they are number crunching and they don't like the results they see. I was like, oh, I don't like this result. What they do is they just change a little bit stuff till they like that number. Oh yeah, then I like this. But then but I just want to point out to you that yes, so that's why when you look at some articles about this confidence interval, oh, this is not 95%, it's actually like 60% if you look at the articles that we just found out over here. Say 95% confident but only show up 60%. Depends on, I mean, there are a lot of other factors that they do the articles there, and that's the reason why sometimes the statisticians think about this number, I don't like these numbers, I want it to be more, big or small or something else. So they will increase or decrease this confidence level so that till they like that number. Same thing with, party politicians like, Democrat, Republican, whoever it is. If you don't like, if people doesn't like that number, they can always call a statistician to change it. Which is, I mean, for me, it's like kind of like, not a good idea. But I will tell you that majority of the time we use 95%. Okay. So this first box is for the confidence level 95%. And then confident that the interval from these two boxes is where you do your lower and your upper. So if you look at this Democrat one, so it will be the 44% here, because the lower is 44 and the upper is 52. Okay, so this is where you put in, and then does contain the true value of the population. The last blank is what is the context is about. Okay, what is context again? What is this What is this 4452? This context is about. I'm just putting it down here. I'm going to type. Actually, it's quicker to type than my handwriting is horrible. The context for this is going to be parentheses. This is what you're going to type in. Population proportion of all American who voted for Democrat. Okay, so this is what you will be replacing here. Okay, don't write the word context in the test, otherwise you get full points. So because this is the word proportion is very important. Then the context in this case is those who vote for the Democrat. And the word all is also important. So I am going to move that follow here. So I do not want to, let me remove this follow. And I'm going to remove the context because that is actually, I don't want this. Just removing all. Okay, good, gone. So this is the context of this thingy. And there are few important features you need to write down. The word proportion has to be there. And the word, sometimes you have to insert the word all. If you don't have the word population, because again, what we're trying to write down here is this interpretation is always go for population. So sometimes population is used, sometimes the word all is used. So this is the very key items that I'll be looking for. So, and then there is also another keywords that I've been looking for is the word confident. So these are the keywords that I'm looking for, besides filling the blanks here. So confident, population, or all. If you have population, then you do not need to use the word all. But if you have, oh my God, sorry. Oof. I did not like, sometimes this is, sorry. All American who voted for Democrat. Okay. So the word proportion is here. The word all sometimes can be removed as long as you have the word population. Okay. So the word all can be removed if you have the word population. So that means you use either one of this. Okay. So if you want to use the word population, then remove the word all. If you want to use all, you can remove the word population. So Again, these are the keywords I'm looking for here in your test. Without the word confidence, without the word proportion, without the word or, then spell this word, then you will not get the full points in this case. Okay. Questions you guys have in the first page of this? Yeah, I'm taking this very slow so that you guys absorb this a little bit more. So the next part we have is the incorrect way to interpret confidence interval, means this is the wrong way to interpret. Do not use the word chance. Use the word confidence. So if you replace the word confidence with the word chance, no good. Okay. And also the second incorrect ways that people will do is the word sample. Okay. Again, we are not predicting the sample, we are predicting the population. So the word population has to be there. But if you use the word sample, it's no good. And sometimes the interpretation that you guys did here can be written in a passive way. Or what I mean by passive way means you can jumble up the sentence of the structure here, like Spanish. You know, usually when people learn how to speak Spanish, they read it backwards or something else like that. So you can say that the confidence interval for the population proportion of all Americans who voted for Democrat is between 44 to 52% with a 95% confidence. So you're doing this backwards, which is fine. I'm totally cool with it. So we call it a passive or active way to write down the words here. I am totally fine with this class as long as the keywords are there, the word confidence are there, the word proportion are there, the word population are all in there, and then make sure you have the 95% and the 44 and the 52. So those are the words I'm looking for, no matter how you write it. So what happens in your homework, sometimes your homework question, this homework, when you do this section is is multiple choice. They sometimes rearrange the words, so make sure just like, in the passive way. So just want to point out, make sure you read the question carefully. Again, the keywords are the one that I'm talking about. Make sure you have the word confidence, proportion, population, or the word all. It's my third time repeating this to you guys. So make sure in your test, I am looking for that. Okay. I think in your test, it is mostly not multiple choice. It's an open-ended, means you have to type it out. Okay. So so this is called the confidence interval. Questions before we continue with critical values? So what is a critical values? Critical value is a number that separates the statistic becomes significantly high or significantly low for those who are not statistically significant. Now, we did this before. If you remember your range of rule of thumb, we find out that to separate between low and high, we take the mean plus minus 2 standard deviation. Okay, so this is what you learn in chapter 3 using range of rule of thumb, or using the empirical rule that anything that is or z-score, anything below -2 is low, anything above 2 is high, and anything in between 2 is no. This is where using the 5% rule that we mentioned about. Okay. So this -2 and 2 is what we call as the critical value, CV. Sorry, I should call. This is called the critical value, the -2 and 2. This is the number that separates between the low, significant low, or the significant high between those. So this critical value that you see here is denoted by Z alpha over 2. And the reason why it is alpha over 2 is because the alpha that we have here is 5%, is being divided by 2 sides, one on the low side and one on the high side. That's why this area is alpha over 2. So 5% divided by 2. The reason why is because it has to be shared among both sides. That means right in the middle is a 95%. Okay, that means, and it is symmetrical, it's normal and symmetrical. So that means there's a reason why that this fellow has to divide by 2. So how do you find this critical value using StatCrunch? Okay, so for StatCrunch, you will use your normal calculator like what you did in chapter 6, but make sure that your first box is M, your mean is 0, your standard deviation is 1, your first box is blank, but the second box is alpha over 2. And what is alpha in this case? Alpha in this case is the opposite of the confidence level. As I mentioned, if you finding 90%, then that means 90% in the middle, then the alpha will be 10% if it's 0.10. Again, StatCrunch doesn't like percentages, they like decimals. If you do 95%, like what we just did here, that means your alpha will be 5%. 99%, that means right in the middle is 99%. That means these two sides will be 1% or 0.01. Now, let's figure this one out using your StatCrunch. Now, let's do the 95%. Now, we know 95% in this case is plus minus 2. Unfortunately, plus minus 2 is wrong. But David, what do you mean by wrong? You studied this from chapter 2 or 3, right? That your margin right range of rule of thumb is plus minus 2. Now, why you say the plus minus 2 that you did here is wrong? The reason why it's wrong is because it is an estimate. Okay, so we are not using the real numbers, but today we are using the real numbers. Okay, and you'll find out that it is not 2, it's close to 2. Okay, so let's figure that number out using StatCrunch. Okay, where's my StatCrunch? There you go. So go to your, I still kind of shocking some of you guys doesn't know where StatCrunch is. Please do not go to the search engine and search for StatCrunch. That is not the way that you guys find in StatCrunch. No. This is not the right way to do it. I was kind of shocked. You have to go into your My Math Lab, your homework. StatCrunch is right here, and you go in here, and this is your data set. So in your finals, if someone asking me how you get data set number 12 or whatever data set, I will just tell you I have no clue. You've been taking my class for almost a whole entire semester and you have no idea where the data set at. Either you're not paying attention in class or you're simply not around. This is very dangerous class. Okay. So this is the StatCrunch. So we're gonna go open up with the normal calculator like what you guys did in chapter 6. So stats calculator normal. Okay. Mean 0 is 1, and we're gonna take 5% divided by 2. Okay, this is the 5% we talked about here. It is not 1 point, it's not 2, it's actually is 1.96. So this critical value should be plus minus 1.96. Okay, it's not 2. Okay. The reason why we use 2 in this case is because to make life easy, plus 1.96 is close to 2. And in StatCrunch, when you type this, they only use the left side if you do less than. And if you use greater than, then you will do only the positive side. But because we know that it's symmetrical, then the answer has to be plus minus. So it depends on where you put your symbol is. You can also tell by the shading piece. So this is the high piece, the low piece means you do the less than symbol, but the answer is still the same, 1.96, one's plus, one's minus. Okay. Now, this is for the 95% confidence level. So that's why we don't use -2 and 2 anymore in these finals. We replace this by plus minus 1.96. Okay. And another thing about your online homework does not like plus minus sign. So that means you have to write this answer twice. One for positive and then one for negative. Make sure you separate these two numbers with a comma. Okay, so don't write plus minus 1.96, they will mark you wrong. Now, what about 90% confidence? 90% confidence is where 0.10. So that means this fellow is 0.10. So actually the critical value for this case is plus minus 1.645. Okay. And for 1% or 99% confident in this case, the value in this case will be plus minus 2.576. So these are your critical value for 90, 95, and 99%. As you guys know that it's not longer using 2 anymore. It can be 1.6 or it can be 2.57, 558. So it depends on the questions you have in this case. Okay. Right. I just showed to you just now. How many I just showed you how you find it? It's right here.
No, I'm talking about like where did you go directionally? You said you went under stat.
Stats, calculators, normal.
Oh, okay. Thank you.
Right here, stats, calculator, normal. Yep. Another thing is that I know that there are quite some students here did not pay attention or did not even watch the videos or do anything when I teach you guys online, and I can tell by looking at your tests. This is super important class. If you are not paying attention, yeah, I'm not going to name people here, not watching my videos, the test score will tells me. Very easy. Okay, so that is taking attendance right now. I don't know how you're paying attention right now. So class, you're taking this class, and if you do not want to come to participate in my Zoom, at least watch the videos. And if you doesn't want to watch the videos, you probably have to take this class over again. Period. Okay, and I think you guys know about my pre-test already. Okay, if you took my midterm, you should know. Did my pre-test looks very similar to the midterm? And I think you guys know the answer already. And again, if you did not watch my video or did not participate in my pre-test, I already told you to. Oh my God. And you still don't want to do that, you know what? I will say, please take this class again. That's why I will tell you straight away. I'm just pointing out blanks. I mean, just point blank to you guys doing the prep talk for you guys, because I can tell some of you guys that did really poorly on the test here. Just I can understand because you're not paying attention in the class, or you're not doing any work, or you're not doing anything and not doing homework. Those are the stuff that I'm worried about, because this class is a college level class, not a high school or middle school math work. To point out, no more prep talk for me. You guys do what you want, and I'm trying to help. As I mentioned the first day of class, I can help you, but you have to learn it your own. You have to earn the grade, not going to give you the grade. Okay. Gonna say that. Next, margin of error. So we talk about the margin of error. Usually the margin of error comes with in the confidence interval with the plus minus 4 or 3, 2, 1% here. So this margin of error, it is what we call as the maximum likely difference that the sample statistics will contain the true value of the population. So this is the maximum likely difference. So to find this margin of error, the real statistic way is to multiply the critical value with the standard error. Okay, but as I mentioned that in early on, we do not do this. Okay, so that's why when you look at your formulas or you happen to solve this, they will use this. Again, how do you find your margin of error? Margin of error is taking the upper minus the lower divided by 2. This is the how you find your margin of error in this case. So make sure you guys know this. And again, we do not know, as I mentioned early on in your test, I don't come up definitions in your test. So make sure that you do not need to draw put down, oh, margin of error definitions is this. You do not need to do that. Okay. Mostly I won't come up definitions. Okay. Requirements, yes. So in order for us to use this 7.1, finding the confidence interval for the population proportion, the first requirement is make sure that the sample is a simple random sample. Sometimes I shortcut this as SRS, which stands for simple random sample. And yes, you can use SRS in the test. What does that mean is in the question, make sure that you have the word randomly in there. Like the example that we just used here, the word randomly selected. So this means that this is SRS. Okay, so make sure you read the question, the sentence carefully. That will be the sample, SRS in this case. Next, make sure that it fulfills the binomial distribution. What is a binomial distribution? One, make sure that you have fixed number of trials or sample sizes given to us. Two, make sure that all the trials are independent. Three, two categories. And four, the probabilities of each trial has to be the same. Okay, so these are the second requirements, the binomial distribution, which you learned in chapter 5. It will be used again. And the last requirement is make sure you have at least 5 success and at least 5 failures. What do I mean by success and failures? So if you talk about Republican and Democrat, then I need to have at least 5 who are going to vote for Republican and at least 5 who vote for Democrat. If you talk about yes, no, that means I need to have at least 5 who answer yes and at least 5 who answer no. Boy, girl, at least 5 boys and at least 5 girls. So again, make sure you have 2 outcomes. You cannot have more than 2. If you have more than 2 outcomes, this 7.1 is not applicable. You have to go on to the next statistic class to learn for more than 2 outcomes. Okay. So now here is your StatCrunch. How do you find this? I will show it to you. This is the StatCrunch to find the confidence interval. Okay, you go to stats, proportion stat, one sample with summary. So make sure it's different to find critical values. Critical values, you go stat calculators normal. So now if you want to find the confidence interval, you go to stats, you go to proportion stats, one sample with summary. So this is where if you want to find the confidence interval, you have to go this route. Okay, proportion stat, proportion stat, one sample with summary. And they will ask you for 2 things. Number of success. Number of success means is how many people vote for Democrat, or how many people say yes, or how many people are boys. That means the question will tell you what is the success they want. So based on the example we did last time, if you remember, you talk about just Democrat. 20 people vote for Democrat. So your X in this case, or number of success, is 20. Number of observation is N, or number of trials or sample size. There are 43 people here. And then what you need to do is there are 2 perform options here. One is a hypothesis testing and one is confidence interval. The hypothesis testing is used if you do chapter 8 and 9 and 10. Okay. Confidence interval is used when you do chapter 7 or chapter 9. So when you guys do confidence interval, make sure you click on the confidence interval. If chapter 8, when you do next chapter, you do hypothesis. And when you click on the confidence interval, they will ask you for what level. Again, if you are using 95%, you do 0.95. Otherwise, you use whatever percentages they want you to do in the question, 90, 80, 99, and then you hit compute. Okay, so this is what the result looks. This is what you enter, and this is what the result will look like. Okay, So just the method is standard wall, so don't change the method. So we are doing the proportion here. So here is what the result looks like. So make sure you pay attention on the result. The count is your X, how many people vote for Democrat in this case. Total is your N, how many students total in the classroom. Sample proportion is where you take X over N. We did that before already. When you take 20 over 43 is 0.465. So this is your sample proportion. We also call sample proportion P hat. We also call sample proportion best point estimate. Okay. Standard error, you do not need to worry about standard error because we do not use that in this class. So you can skip this one. The lower and upper limit is the one that you have to know. So what is the lower and upper limit? That is your confidence interval. That is the range that those who will be voting for Democrat in the whole population. Okay, so it's between 31.6 to 61.4. Okay, so that means the confidence interval is no longer 44 to 52%. It's going to be 31.6% to 61.4. So the lower and upper in this case is these two. And you can tell that this question did not give us the margin of error, E. Okay, so how do you find the margin of error? You find the margin of error taking the upper minus the lower divided by 2. So you just parenthesize that. 0.614 is the upper, minus 0.316 is the lower, close your parentheses, divided by 2. And this 0.149 or 15% is your margin of error. Okay. Now, do you want a 50% margin of error in this case? The answer is no. You do not want a 15% of margin of error. The reason why you do not want a 15% is because the margin of error is too big. Usually your margin of error is around 1, 2, 3, 4%. Even 5 is the most I will look at it. But if I see a margin of error is 15%, like what we calculated here or found here, that means the whole project or the whole things that you do will be put in a trash can. That means I would not like to see it. And the reason why this margin of error is so huge that is not accountable for or not trustworthy is because your sample size is way too small. Okay, so you only got 43 students and you're trying to take 43 people and try to predict how many million are going to vote this coming election, like 150 million people. 43, try to predict 150 million people. That is no, That's why I say the whole project will be all in the trash can because your sample size is way too small. And how can I know that? Looking at margin of error. Because your margin of error is too big, I know that your N is very small. Usually your margin of error is usually 3, 4% or 2% like this. That will usually signifies that you use a big N. Okay, not 43, maybe 4,300 or 43,000. Okay, then you will see a bigger margin of error. Your margin of error is small in this case. So that's how I kind of it's kind of what that you do in this case, and that means that the bigger the N, the better it is. Okay. So this is how you find the confidence using StatCrunch. You will see this again in your next class tomorrow. Okay. So this is the formula that I mentioned early on. To find the margin of error E, you take the upper minus the lower divided by 2. And sometimes the question also give us the point estimate P hat. So in this case, if a question does not give us P hat, you take the upper plus the lower divided by 2 instead of minus. The only missing part that is missing in this formula is make sure you put parentheses around that. Okay, so I think you guys know about your calculators. They do all this operation. Okay, now how many ways can you write confidence interval? There are 3 ways. Okay, so let's say this is the confidence interval you found in StatCrunch. So this way is StatCrunch is usually given us on the last way. So usually you write this as 0.316 in parentheses and then 0.614. Again, that is your low and your high, or low and upper in this case. Okay, so this is one way to do it. So again, if the question did not specifically ask you to write the format, you can pick either 1, 2, or 3. There are one of these ways. So it's up to you how you write it. But I would suggest if I don't ask you a specific format, then I ask for you just write in this way. So it's make your life easy. If you want to write in the first way will look something like this. Okay, so this is the first way that we talk about. The P stands for population proportion. And the first blank you use here is where you put the lower, and the second blank you put the upper. And as you guys know that the lower for this question is 0.316, and the upper in this case is 0.614. Okay, so this is how you do the first way. That you can also write this way in your test. I'm not picky if the question doesn't ask for what form they want. And also you can write it in the third way. Now this way is a bit more work. The reason why I say it's a bit more work is because they want you to write in P hat plus minus E. Now what is P hat stands for? P hat stands for sample proportion. So in StatCrunch, the P hat in this case is 0.41465 plus minus E. And what is E? E is the margin of error that we just calculate. Remember, you calculate the margin of error taking the upper minus lower divided by 2. That's the E. So this is going to be 0.149. So there are 3 ways for you to do in your format to write confidence interval. Again, in the test, if I don't specifically ask you to write what format, then you can write it either one of this way. But if I specifically ask for, then make sure you write in the way that I want you to write it. Okay. So again, StatCrunch is using the red one. Okay, which is in here. Now, this questions, number one example is asking us that is given us that your P is given us by 0.179 and 0.321, means this number is your lower, this number is your upper. Now, I'm not, the question here is asking us to find write this in the form of P hat plus minus E, okay? And we are not writing in this form because it's already done for, so we're not going to X that follow up. So the question wants us to write, so the question wants us to write that way. So how do we find P hat and E if I know the lower and upper limits? We will be using this formula. Okay, we'll be using this formula. So if a question gives us lower and upper limit, the P hat is taking these 2 and add it up and divided by 2. So in order for us to find this, so the P hat, again, I just use P hat. This is where you take your, oh my God, what happens to my, something happens. Upper plus lower divided by 2. Which will be, there you go. Just get rid of that. So upper in this case will be 0.321. Lower in this case is 0.179. Add them up with the parentheses and divided by 2. And if you use your calculator, it will be 0.25. Okay. So again, you just add the upper 0.321 plus 0.179, close your parentheses. And then you divide this by 2. That's where you get the 0.25 at. Okay. And to find the margin of error E, you subtract it. So now you put in the parentheses, subtract 0.321 minus with 0.179, close the parentheses, and then divide this by 2. You get 0.071. So in order for you to write this in this form, P hat plus minus E, your answer will be 0.25 plus minus 0.071. So this is your answer for this case. Okay. So we were using this formula. So anyone have any questions so far with number first exam? I think this is what you get in your first homework question in 7-1. Or so what, first or second one? Second, question number 2. An important issue facing American is a large number of medical malpractice lawsuits and the expenses they generate. In a study of 1,028 randomly selected medical malpractice lawsuits, it found out that 856 of them are later dropped or dismissed. So this is type of questions that is a categorical type. Why I say this is a categorical type is because when you bring a lawsuit to a court, either it is guilty or not guilty. So you can tell that it is one way or the other, and it's a binomial because you got 2 outcomes. So you can kind of figure out that this is 7-1 that we're doing here. And this 1, 2, there are 2 numbers found here. And this 1228 is your N, which is saying your total numbers of outcome, total number of trials here. And 856 is your X. And I want to always tell you that your X is always less than N. So if you swap these variables around, you probably get it wrong. Okay, so make sure you know that the X is always less than N, or N is greater than X in this case. So make sure you guys know this. Okay, so question A is asking us is, do the requirements, asking for the requirements to find the confidence interval for population proportion satisfied. So they're asking for the requirement check in this case. So how do we figure out the requirement here is we have to go to the requirements. So if you remember the requirements, yes, these requirements is also important. So these are the requirements, and I will give you a little bit of towards the end of the semester before you take your finals. I will kind of like give you this kind of like bring out what are the requirements here. The first requirement says that it has to be SRS. So again, we're gonna do that. So the first requirement stated, oops, sorry. This is what you're gonna do in my test. So make sure you guys, so the first requirement has to be SRS. And since this SRS, it has the word randomly selected in the question. So this will be checked. Okay, not to be necessary to be caps. Next, it has to be binomial. Okay, this is your second requirement for that. A binomial consists of a number of trials n, independence, 2 outcomes, and the problem is the same. Now, we know n because n is given by 1,228. So that's good. First condition is satisfied. Independent. Now, independent is based on the lawsuit. So now I just figure out what independent means. Independent means that one lawsuit doesn't depend on the next lawsuit. That means they are totally independent. So let's say that you bring a lawsuit to the court and the judge say, oh, guilty. And then another person bring a lawsuit to it. You think the second lawsuit is totally independent, or is it depending on the first lawsuit? So the judge said, oh, the first one is guilty. The second one is not guilty. Or is totally is that totally independent? So we kind of know it is independent because the second, third, fourth is totally, it depends on what evidence you bring in. The judge will look at previous lawsuit and say, oh yeah, this one is independent, so this is guilty, this one is also guilty, right? So it's totally independent in this case. And third, it has to be 2 outcomes, either guilty or innocent, right? And then lastly, the probability of success is the same. So what do you mean by probability of success is the same is, let's say you bring a lawsuit. What is the loss? What is the lawsuit? Is it guilty or innocent? Is 50-50 until you bring the evidence, right? Then the judge will judge it. And then the next person bring the lawsuit, also 50-50, innocent, guilty. And the next person bring 50-50 until the judge will, see the evidence you have. But before you bring it out any evidence, the judge have to be on 50-50. Hopefully, that's what the judge should be doing. So every single lawsuit that you bring is 50-50. That means that the probability is the same for each trial. So that means that your binomial in this case will be also checked. What happens to my PDF here? Something happens. And the third requirements we have is it has to be at least 5 success and at least 5 failure. It's the last one we're going to do here before I let you guys go. So what do I mean by at least 5 success and 5 failures? Success in this case means is your X. Okay. Success in this case means is your X. Oops. Ugh. Sorry. Success in this case means is your X. And you find out that your X in this case is 856. This is the question given to us. So if 856 are dropped, then how many are not dropped? Okay, so that will be the failure one. So in order for you to calculate the failure one, you just take 1228, which is the total number, subtracted by the 856. Okay, so 1228 subtracted by 856, that will be 372. But the main part here is this number 856 and 372 at least 5? Yes. Okay, so this is checked. So if you see all these 3 requirements are checked, then the requirements are met. But if one of these requirements does not check, then the requirements do not met. Okay, so make sure you guys do this in your test. If I ask you for a requirement check, make sure you tell me. Don't just solve you in the test, just label SRS, binomial, whatever. But make sure you check them. Have either the checkpoint like this. Okay. And also a lot of students, once they finish check, they forget to write the requirement met. So these are points for you. So if you just type without met or without the word check next to it or the checkpoints next to it, you won't get the full points in your test. So make sure you put the word check on next to it and the requirements met next to it. Okay. So this is how we do part A here. We're going to stop now. We're going to continue this on tomorrow. So we will be doing quite a bit of, this is tough. I'm not saying this is easy. So I know there's no homework due on this Wednesday. I would highly recommend you to start working on your chapter 7 homework, which is due on next Wednesday. Okay, so you got 3 or 4 homework due on next Wednesday. So I would highly recommend you to start working on your homework here. So don't wait till the last minute. And if you have any questions, you can always ask me. Okay. So I'm going to stop sharing here. And this is the end of today's class.